8.2 is about translating graphs. Okay, so the basic vocabulary here has mostly to do with types of functions when you're translating. And so basically, we'll come back to this vocabulary sheet in a second. Let me just show you some examples. When we're talking about our basic functions, okay, we're going to look specifically at parabolas, which come from y equals x squared. And we're going to look at the absolute value function, which comes from y equals the absolute value of x. Okay? And so y equals x squared looks something kind of like this. And so all parabolas can be found by variations of y equals x squared. So we'll talk about how to find the equation of a parabola maybe that is slid left and down, and how to incorporate that into our equation y equals x squared, so that we can find the equation more easily for the second graph. The graph of y equals absolute value of x looks something kind of like this. And can be moved in similar ways, and the rules can be written similarly if you see the absolute value function also translated, which is what we're going to be talking about today. Later we'll talk about other ways to change it, but today we're just going to talk about translation. So the parent function is the most basic form of a function. So those are the ones I was talking about. They're the ones that you can change. Oh, sorry about that. So a parent function is the most basic form of a function. It's what you can transform to create a family of functions. So our examples that we're going to be looking at in this chapter are y equals x squared and y equals the absolute value of x. Okay, so they give an example here where y equals x squared is the parent, and you can transform that into y equals x squared plus 2, or y equals 3 times x minus 4 squared, and we'll learn later about what these extra elements will do to the function. The family of functions are the groups of functions with the same parent. So, for example, these two absolute value functions are members of the family of the parent y equals the absolute value of x. And then the last thing we're going to talk about is the vertex. The vertex is the easiest thing to look at when you're talking about translations and trying to figure out what the equation is. And the vertex is the point where the graph changes direction, okay? So from increasing to decreasing, or from decreasing to increasing. So when we're talking about our other examples, I'm going to go back to that page. The vertex is just this point right here that I'm drawing, or on the absolute value graph, right where it changes direction, okay? So it's an easy spot to look at the coordinates to see what's happening to your entire graph. Go ahead and pause the video if you need to copy down these vocabulary words. So what you see here is that you see the parent function in black over here and the image in red. And we want to figure out what kind of transformation this is. The options for transformation are a reflection, a rotation, or a translation. Those are our three options. Those are the only things that could be happening. And when I'm looking at this right now, I know it's not reflected. It's not rotated, so it has to be a translation, okay? Has to be a translation. So we're going to describe the translation. I'm going to describe the translation. And I'm just going to do general terms for right now. I know that from the parent function, it's going right and down. Or down and right, either way you want to think about it. And now let's use a little bit more specific information. So I like to look at the vertex. The vertex of the parent function, as I told you before, is always at 0, 0. But then when we look at our image, the vertex is at 2, -4. And so what you would be tempted to do right away is just to assume that it's increasing by 2 on the x and decreasing by 4 on the y. But you don't actually want to do that. You want to check another point. So what I notice is that when I go over 1 on my image, or on my original, I go up 1. And same thing on my on my image, is that when I go over right 1, I also go up 1. So we can compare these 2 points. So that point on the original function is 1, 1, and on the image is 3, -3. And what I notice is that the x is still changing by 2, the y is still going down by 4. So I can write my general rule as we have on the previous section and on your packet, that xy becomes x plus 2 and y minus 4. And so now we've described the transformation. Now we need to write an equation. This is the new piece of information that we've got here. We need to write an equation. So our original equation for our parent function is y equals x squared. And I need to write an image. And I know that y equals x squared is going to be included in that. So I'm just going to write a y, and I'm going to write an x, and I'm going to write a squared. And I know that there's going to be an equal sign somewhere here. Now I need to add in these elements of the x plus 2 and the y minus 4. So this is where it gets a little bit tricky. So if you think about another example, I'm going to go to a new page here. If you think about a different example, if you think about your age, let's say x equals 24, that's standing for your age, okay? If you wanted to increase the x by 4, right, you would add the 4 over here, because then x would equal 28, right? But if you wanted to explain this as x equals 24 plus 4, if you wanted to explain this in terms of x, you're going to have to subtract 4 from the x to say that x minus 4 equals 24. So by subtracting 4 from the variable x, you're making x equal 28, which is 4 bigger than where it started at 24. So when you think on your equation on this other one that you're going to do x plus 2, that's not true. You're going to do the opposite. You're going to do the exact opposite. So maybe you want to write that down. You're going to do the exact opposite when you're doing your x values. So instead of doing x plus 2, you're going to do x minus 2. And I know I don't want to just square the 2, so I'm going to put this in parentheses because I'm going to take my whole quantity x minus 2 and square it. And then when I look at my y minus 4, oops, let's get a highlighter there. When I look at my y minus 4 and my y, I know that I want to do the opposite. I want to add 4 because that's what's going to give me a y that's 4 smaller than what I originally started at. So now you look here, you've got your equation, and sometimes it's nice to have it in the y equals form. So maybe we're going to subtract 4 from each side, and we've got our final equation, y equals x minus 2 squared minus 4. And now there's an easy way of getting any point on the image. So now I'd like you to try it on this example. We've got the parent function in black. This is the absolute value function, y equals the absolute value of x. You know that it's the parent function because you can start with the vertex 0, 0. So go ahead and see if you can write the equation for this red image of the parent function, y equals absolute value of x.